Okay, I am actually a stand-in for Carrie Gilbert, who couldn't make this meeting. So she was the ETC lead, the head of our working group. I am just a member of the working group. Don't shoot the messenger. The current lead, can everybody hear me okay? Should I go like this? Okay. The current lead is Swara Ravindranath. I think I got that right. And Vicki Laidler is the lead of the developers team for the ETC. And there's been many people, even some of them here, that have worked on this with me. Let's see, I'm gonna go like this. This is going to be hopefully a brief set of slides. It's just going to be going over the key concepts. I'm going to give a quick tour of the JWST ETC, the layout, and then the user interface, and then I'm going to do a quick demo for you to show you how it works. Okay, this is my caveats page. The ETC is still in development, so what this means to you is that, of course, things could just change under your fingertips, and we do expect things to be changed, but it should be like Jeff was saying, about 80% there. We welcome that we do welcome your constructive feedback at this moment in time still. So, I mean, there's still opportunities. That's the positive of being under development. You still have an opportunity to provide input that we can actually use. So, please take a look at the ETC, practice using it, and let us know what you think. I'm going to show you where you can provide feedback in the ETC tool itself. The development version from July 2016, is the one that I'm going to be showing with this demo. It's the one that's currently available. And then I'm going to share the link at the end of the slides, and I'm going to ask people not, because it's not very robust yet, I'm going to ask that you don't run it while I'm giving the talk or I'm doing the demo. Of course, we're going to work on the robustness before the actual release with APT, along with APT release. All science modes are available in this version, except for nearest source and near-cam coronography. There may still be some missing features, some gaps in features, and some usability issues that you might find. Another word of caution. It's underpowered, as I said before, so lots of us can't be using it at the same time. So to prevent any problem, it'll be just me, hopefully, in this room. Okay, key concepts of this ETC. We organize our information into workbooks, and the workbooks are persistent and shareable. So if you log in with a user account, which you can create at the very beginning, you create an account, then you can, if you continue to use that account, if you develop calculations inside of a workbook or multiple workbooks, those workbooks will be remembered for you the next time you log in. But if you're logging in anonymously and you're using the tool, those calculations, of course, won't be remembered. We have, the way this works is, the workflow is going to be to define one or more sources. The key parameters of the sources I'll go through with you. And then to install those sources into scenes. These are little postage stamp areas where we collect all the sources together in an area of about like 3 arcseconds squared or 2 arcseconds squared. And then those scenes and sources are reusable. You can use the same sources in different scenes. You can organize the scenes differently, spatially. And you can reuse them for multiple calculations, for example. We adopted a copy and modify approach. So you can easily grab an existing scene or source and like I said, and just plunk it into a new scene. There's auto update, so that changes that are made on the fly basically flow automatically through to the associated forms and calculations. So you'll see what I'm talking about when I show you the layout. I wanted to just say a word because I talked to a few people who had actually run the ETC or tried to run the ETC and thought of it as an old way of doing things. One that they were more familiar with, which is that it calculates the exposure time from an input signal to noise that you give it. And this is not the way this one works. I wanted to state that up front. The way it works is that you develop your calculations by specifying your source parameters, specifying your instrument and detective setup parameters, and those two last things from those two things, an exposure time is determined, and that is used to calculate the signal noise. And so the product, really the product is a signal noise, either a plot for spectra or a data point on a plot for imaging modes. Okay, so this is the first page you see when you log into the ETC. It will ask you if you wanted, you can use any number of available workbooks by just clicking on load. I really haven't explored these buttons, so I don't really get they look obvious, copy and remove. I've loaded existing workbooks and worked from them, and I've also created my own workbook from the start. Okay. Let's see. The first slide, I moved this up to the first slide. It used to be the last slide, but I think it's important enough to mention here. There is help, okay, and it's on the previous form, if I can show you where I was. It's arrived at by clicking help in the upper right-hand corner. I'm sorry that the fonts are so small. I never really liked that the fonts were small, but they had to fit a lot of information onto one page at a time. So that's why it is. But if you click on help, you have a pull-down menu of possibilities here. There is now a user's guide there with a general overview of how the ETC works. I was able to find the answer to one of the questions that was actually asked this morning about the background, so there is information there, useful information there. There's a quick start guide. I don't know if that's actually finished yet or not. This is where you would provide feedback in the community forum area. You can provide feedback there. And then there's a list of known issues, if you're finding that you're getting bogged down and don't understand the way something works. Okay. Okay, this is the scenes and sources page. So this is the first, what I want to show you here is the layout. The pages that you see are visible by clicking on these tabs at the top. The first one is scenes and sources, and this is the logical workflow. You'll define a source first, and then you will collect a number of those sources and put them into a scene, a named scene. And then that named scene, if you select it, will be shown down here in the little sketch that we provide for your sources. And a source spectrum, if you've created these sources, you would have had to insert a source spectrum type. And we have a number of templates that you can select from. And that will show up here. Now, this is just the input page to the ETC. Right, so no calculations have been done yet. The calculations page is the next tab that you see here. And so I'll show you a picture of that, I think. Oh, first I need to say something about the selections. When a source is selected, it shows up as a yellow box, a pure yellow box. Then it shows up, if that source is used in in a scene, the scene will be highlighted in green. The fact that you've selected both the scene and the source means that you want to display the scene down here, and now they appear in this hatched green and yellow color. So this will help you keep track of your navigation, just using these color keys. Yes? Oh my gosh, okay. Got to really roll here. So I think I just said this. You can actually select, as I showed in this previous slide, you can actually select the source directly in this sketch right here if you want to modify source parameters here. Okay. So this is the view of the calculations page for an imaging calculation. So the set of calculations that you're doing, this is the calculations page. Remember, I clicked on this button here to get there. So the calculations that I've made are all here. This green information, these green check marks here, don't mean that they're getting plotted. It means that the calculation worked just fine. You'll see a yellow triangle or a red something that will indicate if there are warnings or errors. And you can see those warnings or errors here. If you click on these tabs, they'll show a list of warnings or errors. I have selected 1, 2, 3 calculations to plot. And that's what's showing up down in the bottom here, the results of the 3 signal and noise calculations for these 3 calculations here. And again, this is just a picture of the 2D signal noise ratio that you see. And then there's another tab that shows that on the detector, signal noise ratio basically on the detector. Okay. So those, the bottom half of the screen is basically your outputs from the signal noise, from the ETC calculation. And I think you've noticed that there's a list of, this is this is for a selected wavelength that you've indicated when you select your source parameters, you indicate a characteristic wavelength that you want your results reported at. So this is just a sort of a sanity check table that shows all of the results at once for that wavelength. Okay. So like I said, we talked about reusability there, so I don't need to do that. Okay, help menu again. I think we can go on to the demo now. So let me escape this. Okay, I've already got this is the entry page. I've already kind of logged in. I had to make sure everything was going to work. So instead of creating a new workbook, I'm going to show you one where I've already kind of created some calculations. So I'm going to load my sandbox one. Okay, doesn't look like much until I actually select something to look at. So I'm going to look at the first source. I'm going to see what I've done here. I've had to give it an ID. I gave it a name. And then, let's see, a continuum. So I selected black body spectrum. There are lots of others to select from. There's galaxy templates from Brown, etc. You can just explore that. You can upload your own spectral file, spectrum. And let's see, so then I've gone to, you can renormalize your spectrum in a number of different ways. You can normalize at a particular wavelength or normalize in a bandpass, and there are selections of bandpasses. We don't have them all yet, but we're planning on putting in more, ones that make sense. You can add lines to the spectrum, and you can define a shape for your source, a point or extended source, and you can give that, that if you select extended, for example, you can give it different major and minor axis parameters. And then the offset is to say, where does this source belong in the scene with respect to the center of the aperture that you're using for your instrument mode. Okay, so but we haven't defined that yet, so we have to do that. So we go over to, so this is the source being used. So if we go over to, I think it's calculations, yes. Let me just pull this one down, for example, so I can show you how this works. Okay, this is a quick link right here back to the scene parameters if you want to make quick changes from the calculations page. Once you get into the calculations page, you'll more likely want to stay there and just tweak things from there. You define your backgrounds. We had a discussion about this morning, but for now I've just selected the medium background. You can actually give it a positional dependent background as well. But you can give it a date dependent background. I don't know too much about the different models used here, but they do include multiple components. You can go into the instrument setup, and this is where you define, your gradings. There's a pull down menu. It depends on which instrument you selected for your calculation, which you do from here. And then you have a slit selection. I'm doing a fixed slit, near spec fixed slit calculation, so I can pull down whatever slit I want to use. Here is just a throughput diagram through that slit. And then I can click calculate if I'm happy with those parameters at this point. Oh, sorry, detector setup, let's do that. So I selected the matching subarray for the slit that I chose. And that would be, I think, automatic anyway. It'll depend on the slit that gets chosen. And then the readout pattern, which for near spec, there's only two choices right now. I just selected one of them to see, and then I selected the number of groups, integrations, and exposures. And this is what determines the exposure time that you'll get in the end, and I can show you how to find what that is. So you run the calculation by hitting calculate. I just recalculated, and then down at the bottom you should see a sketch. Ooh, that looks weird. That did not look like that before. I don't know why the 2D signal noise ratio sketch looks like that. It shouldn't. Let's leave the detector. It should look more like that, but not as pixelated. I don't know what happened there. The stretch is kind of funny, I think, is what happened. And you can see that this is the bandpass that I chose in the instrument setup, and it's plotting for the spectral, for this dispersed mode. It's plotting a spectrum as a function of wavelength of the signal-noise ratio. Again, the report here, what you see here is the printed results for all the components, etc. So there's an exposure time right, let's see. Where is it? It's in the middle somewhere. So this is the total time required for the entire observation. That depends on the strategy you use. If you use an offset, then it includes time on source and off source. And then this is the exposure time on source. That's resulting from the instrument parameters that I selected, the N groups, the readout pattern, et cetera, that I just showed you. You can rescale this plot, just for example. I'm going to use a log plot. Hopefully, apply. So you can see what's happening. If you want to plot more than one result together, you should see both of those plotted. So I can see both of the spectra plotted. So this is a very powerful and flexible tool, but it has a learning curve. And I think the best thing for you to do is to just go through. I did forget to mention strategy. Strategy is the aperture extraction strategy that I chose to use. And in this case, I set an aperture radius, which is really the height. In the spectral modes, it's really the height that's being extracted, and it's in terms of arc seconds. And then the inner and outer radius I specified for the background measurement in my spectrum, in my extracted spectrum. And then you can specify whether you want to do this with respect to the center of the scene at y equals 0. Remember, this is a slit mode, fixed slit mode, so you can do this at the very center of the slit, or you can do the same calculation at different positions in y. And then you specify the wavelength of interest. This is what I was talking about before, and that gets carried down to the report section, 2.95. So of course the wavelength of interest must be within the band that you selected. But those are the basics of how this works. So I think I can stop there.